If you want to become a full stack developer, I think you should learn this stack. Or if you're already a full stack developer, definitely learn this stack. I've been doing full stack for years, and finally we have a stack with great developer experience. Full stack type safety from database all the way to the client, and most importantly, enables us to write some great user experiences. In this tutorial, we will take a look at the T3 stack, meaning TRPC with Next.js, Prisma in front of the database, and we'll add some email Magiclink login with next-auth and also Tailwind for styling. Let's dive right in. Welcome to this side of the intro. Before we start, I just want to say, if you find something that I could have done better, then please leave a comment. But also, of course, if you really enjoyed the tutorial, tell me. If you want to code along with this tutorial, there is a branch called Start that you can clone. So if you're starting from the repository from the Start branch, you don't have to do this create T3 app. Then you just have to clone the repository and do npm install. But if you want to start from absolute scratch, then you can use this command. And I will show you what that command looks like and what options you get. And I'll show you what options I selected when I created this project. I'm going to copy this npm create command. I'm going to run it. All right, so let's run it. And we will be asked a few questions here. So we'll call this full stack T3 tutorial. We want to use Typescript. We need next-auth, Prisma, Tailwind, and TRPC. Sure, initialize Git and do npm install. So before we start, let's get ourselves an overview of all the steps that we're going to take in this tutorial. And I already crossed step 1 here, which was to install the boilerplate. Then we will continue on the backend and try to finish everything there, and then the rest of the tutorial will be on the frontend side. So our first step is to set up our Prisma schema, and what we're building is an authenticated to-do app. So we'll need to create some model for our to-dos and then deploy that to our database. Then we'll add an email auth provider so that we can send magic links that will authenticate the user. Then we will work on the TRPC routes to create to-dos and delete them and to update them and so on. Then the rest of the tutorial will work on the front-end side. So we'll need to implement the login. Once you're logged in, you should be able to see your to-dos, create new to-dos, toggle them, delete them, and the final step would be to create a real nice user experience by doing optimistic updates. And if you don't know what that is, we will get to that once we reach that step. So let's get started with the Prisma schema. Alright, so this is the schema.prisma file, and we already get some things out of the box from this boilerplate. We have a database URL, which is located in the .env file. So here we can see that it points to a file called db.sqlite, which is inside the Prisma directory. We have some things for next-auth, and we have something for the Discord auth provider, which we will not use. But we will need to add some other secret for the email provider later on. So if we look through this schema here, we have an example data type, we have some account for next-auth, session for next-auth, and a user verification token. So here we can start to add our own data type. So we need a model for to-do. To get this nice help inside the Prisma schema, we can actually have a VS Code extension installed called Prisma, which is great. It will auto-format this file and it will give you these linting errors. So we want to have an ID of this, and let's see if we have another ID here. Yes, here we have an ID that follows the same pattern. So this is what our ID will be like. It's the key of this table, and it will default to a randomly generated ID, which is a good practice. We also want to have created at, that is a date time that should default to now, like that. We also want to have updated at. The reason why I add these is that if we ever want to sort our to-dos based on the creation time or the last one that was modified, it's good to add these if we ever need to do some nice sorting. Of course, the to-do should have text, which is a string that is required. If it wasn't required, you would add a question mark to the end. But text should be required, I think. We have done, which is a boolean, and when we create a to-do, it makes sense that it should be set to false. And now we need to have a relationship, because I mentioned that this is an authenticated app and we want our to-dos to be stored on a specific user. So I will call this field user, and the type of the field is user. So when I save this here, now the Prisma extension helped me out. It auto-completed this, that it's a relation, and it uses the local field of user ID, referencing ID from the user table. So this user ID will be equal to one of the user IDs from the user table. So now if we go up to the user table, we can see that the extension even understood what I needed to do in the user table. So user has a field called to-do, which is a list of to-dos. And I also want to add an S to this, so it's called to-dos on the user. That should be it for the Prisma schema. But just modifying this file doesn't do anything. We also need to make sure that this schema is actually on our database, meaning that we need to run some SQL queries for, or SQL mutations, like create table to do and add all these columns that is part of the to do data type. But we don't have to do that manually. That's what Prisma is for. What we do is npx prisma db push. Your database is now in sync. So I had already done this to this database, so it would say now that my schema is in sync. After it does that, it also generates the Prisma client, and that is the code that we'll actually use to interact with the database, an npm module that we can import. So let's actually use the Prisma Studio to have a look inside of our database. We do npx Prisma Studio. Alright, so here we can recognize the things that we saw in the Prisma schema, and we can verify that we also have our to-do column and that the fields are matching what we wanted. Alright, so let's check something off the list. So we have updated the Prisma schema and applied it to our database. Now our next step is to add an email auth provider. So for that, I will go to source, server, and auth. So here, further down, we have our auth options and a list of providers. So by default, we had the Discord provider here, which I removed, and we want to have the email provider. So let's import the email provider from next-auth provider's email provider, and then we'll add this to the list. Email provider. So this is a function that we should pass some options. So first we have some server options. We need to give it a host. So we can get this host from our env. So we do process.env.email server. And if we don't have that, we can fall back to http://localhost 3000. We're going to set the port 2587, and we have an auth section, user API key, and then we have a password, which is the pass prop, and that should also live inside of the env variables, email password or empty string. So this way we can, inside of our env variables, set what the email server is and what the email password is. So then this would be able to connect to something like SendGrid or Postmark or any email service. Even you could even use your Gmail to send out these emails. We also need to configure the from, which we can have that also in the process.env variables. Email from or default@default.com. So now we're going to try to do something clever here, because if we are in development mode, we don't want an email to be sent at all. We just want to get access to the link that would go inside of an email. So to get access to that link, we could add a function here called send verification request that would get the URL passed to it. And then we could just console log that URL, let's say auth link, or we can call it login link, and console log the URL. But if we're in production, we don't want this function to be here. So we're going to do a ternary operator and check for the node env being production or not. So if we spread whatever object gets returned from this parenthesis, we could check process.env node env not equal to production. So if it's not production, we want to spread an object containing this function, otherwise an empty object. So now this ternary will, if it's not production, it will add this function, otherwise add nothing. So now if we're developing, we can just get this link inside of our terminal instead, logged out, and we can click that. But if we're in production, then the email would go out. There's one other thing we need to do, and that is to npm install node mailer, because that's a dependency that the email provider in next-auth needs. And the final thing we need to do is to add email server, email password, and email from to the env variables, like this. So now we should be able to check off add email auth provider. Alright, so for our next step, we're going to create our router. So conveniently, the stack has an example router for us. So let's just copy that, rename it to to-do, and then we can just modify this one. So we'll call it to-do router. We're not going to have any public procedures because you need to be logged in. So we're gonna have protected procedures. So one thing that we would want to do is to get all to-dos. So this is a query that doesn't take any inputs. Since we don't have any to-dos in the database for now, we can just return a fake to-do here with ID fake. Text could be fake text, and done could be false. So until we get some real data inside of our database, we could just return a single fake to do like this, or actually let's just make two of them. So we'll do fake 2, fake text 2, and we'll set this one to true. Alright, so now we return two fake to-dos, but let's also finish the code for what it looks like to fetch the actual to-dos from the actual database. So as input to this callback function here, we get the context object. So this context object has Prisma and it also has the user session. We're going to do some awaiting of promises in here. So we need to make this function async. So we'll do const todos equal to await context.prisma.todo.find many. And this find many takes an object where we specify a where prop, where we say that only todos where user ID is equal to context.session.user.id. So that's how we get the to-dos related to our logged in user. And this to-do has some extra fields that we're not so interested in sending right now. So to send only ID, text, and done, I'm going to do a map on these to-dos. So what we would do is return todos.map, and we can the structure ID, text, and done, and then just return an object with only those 3 properties. So let's comment this out for now and use this fake data. Now TypeScript is mad at us, so we can keep this, but we don't return this for now. We just console log it. To-dos from Prisma. So now we're done with the endpoint for fetching all the to-dos for a specific user. So now let's add some more endpoints here. This, and we say create. It's a protected procedure, but it's not a query, it's a mutation. And this create procedure needs to take some input. So we'll chain on input here. And then now we're going to use sod to validate this input here. And this input, we want to validate this both on the front-end side and on the back-end side. So I'm going to put this in a types file. So inside of source, I'm going to create a new file, call it types.ts. So we'll import sod. So here we're going to export const to do input, which will be set.string. So the only input we need for this procedure is the text. So it would be a string that we need, because the ID is auto-generated and done should be defaulted to false. So the only thing we need is the string. And we can say to sod here that we want a required error. So what should it say if there's no string here? We could say describe your to-do. And we could say it should have a minimum length of 1 and a maximum length of maybe 50. So now we have our schema for the string and some properties of that string. So we can import that. Import to-do input from types. So we can put that here, to-do input. So now we're telling TRPC what input this procedure must have. And if the input doesn't match our schema, it can say bad request. So what we need to return here is context, Prisma, to do, create the data prop, and then text should be our input. And the input we get as an input here. Now Prisma is giving us a nice error here that a to-do also needs to be connected to a user. So then we say user connect, and it should be connected to the user's ID, and we need to give the user ID that we have on the context session user ID. So now we successfully created that new to-do for that user. So now let's copy the create procedure and continue with the delete procedure. So here we have a much simpler input because we're going to receive just an ID of what to do to delete. So here I will just do c.string, and instead of create we do a delete, and we don't need all of this, and instead of data it's a where again, and we say ID is input. And the final thing we need to be able to do is to toggle a to-do on and off. So the toggle needs two things as the input. It needs to get the ID of what to do to toggle and the desired state that done should be in. So then you can do set.object, and you pass an object where we say ID should be set.string and done should be set.boolean. So here instead of delete we're going to do an update. So where ID, now that we have an object here, we need to do input.id, and then we give it both where and data. So data would be done should be input.done. We can make this code a little bit cleaner even, because we could destructure ID and done here, and then we could make this a one-liner here. Input, like that. So now we have all the API endpoints that we need. We have get all to-dos, create to-do, delete, and toggle. And that should be everything we need. Now let's clean up the code that we don't need. We don't need this example router. And inside the root, this is where we actually give our router to TRPC. So we copy the example router. It's called to-do router and comes from routers to-do. And to-do is to-do router. So now we've given TRPC our router, or we've added our router to the app router. Now we are done with the backend side. So now let's start to look into the front end. So if we jump into the index page, we can see that I already prepared some code here. So we do the use session hook from next-auth React. That's where we can see the logged in state of the user. So we can see that if we have session data, we can say logged in as session data .user.email. And we also have a button where we can do sign out and sign in. So if we have session data, we can do sign out, otherwise we can do sign in. And then the text of the button does the same thing. It says sign out or sign in depending on the session data. The sign in and sign out functions, we also get those from next-auth React. So I think now is a good time to start up our project and try out the logging in. npm run dev, load the page. So we have the sign in button. So what we're hoping for now, when we try to log in, that we get a URL inside of our terminal. So I will do test@test.com, doesn't really matter. Sign in, check your email. A sign-in link has been sent to your address, but of course we know that we're not doing that because it's in development. So we can see that we have our login link in the terminal, which is great. So I can open that page and I get bounced back. Now we can see that we're logged in as test@test.com. We can also try signing out and signing in again at test@test2.com. Try it again. We click the link and we're signed in as that user. So now let's go back to the Prisma Studio. So I'll take a new terminal and npx Prisma Studio, because now we should have some data about these two users. So if we open the user table, we can see those two users that they have been created. So this is stuff that we got from next-auth. So that is great. So now we should start to build the UI for our create to do. We can check off being able to log in the front end. And our next step is to list out the to-dos. So we did add some fake data here. So our next step would be to list out this fake data inside of the front end. All right, let's start to work on our listing of to-dos. So we only want to list these to-dos if we are logged in. So we make sure we have session data, and if we have session data, then we will add some new divs here. And I made some Tailwind styling for these divs. So let's add that, right? So we have not much here yet. We have some layout and then a header that says to-dos. So this is what it looks like now. But we should create a component here that we will call to-dos. And we need to create ourselves a component folder, a component called to-dos. Then there we have our to-dos component. So to get our to-dos, we get some really nice help from TRPC. So we have an API that we can import from utils API. So utils API. So here we have an export called API that is a create TRPC next call that passes in the types of the app router, and that's what creates all the magic and all the nice autocomplete and type inference. So what we can do now is we can do API. Now we get the nice autocomplete. We know that we have a router called to do, and we want to do the all procedure, and on that we call use query, and it takes no inputs. So here we get data, and we'll call data to-dos, and then we get is loading, and we also get is error. So then we can say if is loading, can return a div that says loading to-dos. This icon would be nice. We'll do the same for if is error fetching to-dos. A nice X here. If we're not loading and we don't have any errors, that means that we should have some to-dos. Let's make sure we have to-dos.length. But if we have to-dos.length, we can do to-dos.map. And for each to-do, we want to return a to-do. We need to set a key, and a to-do has an ID, so we can use that as the key. And then we'll pass the full to-do to the to-do component that we're going to create shortly. If we have an empty array as to-dos, we can just return create your first to-do. Now let's create the to-do component. So we get a prop called to-do, and we know that this prop has ID, text, and done. We need to type that also and print out the text here. So how do we type this then? This is a to-do that comes from the router to-do.all. So how do we type this? We know this is one of the to-dos that comes from the procedure to-do.all. Let's add some types to our type helper file. We can import a type from TRPC called infer router outputs. We can also import type app router from server API root, and then we can create the type of router outputs, which will be infer router outputs and passing in the app router. So if we hover this type now, we can see that we have the to-do type here. So let's create the type all to-dos output. That would be router outputs and the to-do router and the all procedure. So if we hover all to-dos output, we can see that we get an array of ID, text, and done. And if we go back to our router, we can see that it inferred the type of the shape, because we're not taking the entire Prisma type of to-do, we're just taking ID, text, and done from those. And TRPC is smart enough to infer these types. So if I were to add another one, extra is equal to a number. If we go back to the types file and we hover all to-dos output, we could see that we also get extra as a number and sometimes not. The second one doesn't have extra. So this is the strength of TRPC, that it looks at the shape of the data and then creates types for us. So now we can export the type of a single to-do by export type to-do is all to-dos output and pass in a number. So by passing in a number, we're saying that we're going to take one of these to-dos in this list. So now we have a type that is inferred from whatever the router spits out. So this is great to use for typing the to-do prop. So we can do import type to-do from types. We can create a type in here. To-do props is to-do, and that is a single to-do. So now we can type this prop here with to-do props. To-do props. So now we have this type actually coming from the TRPC backend that we just built. Let's see what errors we have here. We haven't imported our new component yet. And now we only have 2 warnings, which is okay. So now we can look inside the frontend that we get fake text and fake text too. So that is very nice. Very little code. This is how we get the data, and it's fully type safe from the backend. We can trust when we do our frontend coding that we are doing things correctly and things are typed. So now let's add some nice markup here styled with Tailwind. All right, there we go. We have some HTML. We have the text inside the label of this input, which is a checkbox, which means that we can click also the text to toggle the checkbox. But this checkbox is, of course, dead now. It does not relate to any data. It's just HTML. and this delete button is also dead. So first let's connect our checkbox to the actual data. We'll say value is equal to done, checked is equal to done. And if we look at our fake data again, we can see that the first one should be false and the second one should be true. So we can verify if that worked. Yes, the first one is false and the second one is true. All right, so we can now list out these fake to-dos. But before we go on in this component, we're going to jump to the create to-dos component, because with that component we will be able to create some real data. So I think we can check the list to-dos and move on with the create to-dos component. And the delete and toggle will live inside of this component later. Onwards with the create to-do component. Create to-do. Let's add the component here. Create to-do. Let's see if we have it. Yes, we have it here. So first let's add some markup. All right, so we have a form, we have a text input, and we have a button that says create. Let's have a look at what it looks like. Okay, so we have a form, but it's not connected to React, it's just HTML at this point. So let's change that. So the form needs to have an on submit. And we do prevent default. So we prevent default because we want to control what happens on the submit. We need to create some local state for what should be inside this text input here. We'll call it new to do, set new to do. We'll default it to empty string and import use state. So the value of this should be new to do, and on change and whenever we change this input we want to reset this state. So let's make sure that it still works. Yes, so now we're controlling this input. So now we can continue on the onSubmit. Now we want to validate that what we have in our text input is actually valid for the input to create to do. Inside of types, we actually saved this to do input schema that said it should be a string and minimum 1 character, maximum 50. So let's import that schema into the front end here. To do input. Result is to do input safe parse new to do. So if not, result.success console. Let's just try this. Not valid. So let's open up the console. So if we just try to submit this form, it says not valid. But if I have something that is more than 1 in length, it does not say not valid. So the schema check seems to work. But let's create a nice error message for the user. And to do that, I'm going to use a library called React Hot Toast. So first we need to go to the app and add a toaster. And when I have a toaster, I can show these little toaster messages. So we need to import toast from React Hot Toast, toast error. We can actually show the SOD error. If we do result.error.format.errors, and if we have multiple, we can just join them with a new line. So now let's try it again. String must contain at least 1 characters. So that's a nice error that the user can get. So if we are in here, we return, so we don't do anything more if the input is not correct. But if we are here, we need to perform the create to do mutation. So how do we get that mutation? We have the TRPC API, so we can do it like this. Mutate is equal to api.todo.create.use mutation, and then all we have to do is call mutate. And of course we need to provide the input, which is new to do, and we know that that is a valid input for this now. So now we should be able to try this, and before we try it, we could also change, we could remove this fake data here, and instead of just console logging these, we actually return them. Alright, so now we're ready to try to create our first to-do. First to-do, create. Alright, so nothing happened. We can take a look at our network tab and see that we do have a to-do create. It was a 200 OK. We sent JSON first to do, seems correct, and the response we got was a to do, and this is the to do that was created in Prisma. But we're not seeing it in the front end yet, but if I reload the page, I can actually see it. So when I create a to do, it's successful, but the front end is not updated. And why is that? Well, that is because we have our query that fetches all the to-dos, and then we have our create to-do, but the to-do.all does not refetch, which it needs to do for me to see this new to-do that was added. So how would I solve that? What we can do is that we can tell TRPC that the to-do.all query is no longer valid because I know that I've added more to-dos. So what I can do is that I can say that on settled, we can pass an async function. We need to get access to TRPC so that we can invalidate the cached query of to-dos.all. So to get access to the query cache, we can do const TRPC. We can call this anything we want, but I will call it TRPC. API.useContext. Now we can await TRPC.todo.all.invalidate. So let's see if that made a difference. Second to do. So if we open up our networks tab now, we can see that on page load we fetched all the to-dos, then we did to-do.create, and when that was settled, we invalidated the to-do.all that was there, so it had to fetch it again, and that's why I saw the second to-do immediately. Not immediately, that we will fix later, but after it went to the server and fetched them again, then we saw them. So it was a slight delay, it was a very fast delay, but there was a delay because it has to do another fetch to to-do.all. So now we have a way of creating to-dos, which is great. So the next thing on our list is toggle to-do. So let's jump into the to-do component. Now we need to start to do mutations in this component as well. So we'll import API from utils API, const mutate, we call that done mutation, API.to-do.toggle use mutation. And let's fix the onSettled immediately. let's get access to TRPC from API.use context await trpc.todo.all.invalidate. So when do we run this mutation? That will be when we click a checkbox. So if we take this checkbox and do onChange, take the event, done mutation. So our done mutation expects an ID and done. So ID is ID and done is e.target.checked. All right, so let's try. We'll toggle the first to do. So we see that the toggle was successful, and then we made another fetch. And what we got back was a list where the first one is now true. And if I do it again, we can see that it should be set back false and false. So great, the toggling now works. Let's copy this and do the delete mutation. So to do dot delete, and the delete mutation is when we click this button. So let's do an on click. We do delete mutation, and that expects the ID. And we already did the onSettled invalidate to do .all, so we can try it out. So I'll delete the second to do. And the delete was successful, and then we made another call to do .all, and then we should see a list of just one to do. So let's go back to our to-do list, and we can toggle to-dos and we can delete to-dos. So we have just one thing left on our to-do list, and that is optimistic updates. And what do I mean by that? Optimistic updates is when you don't wait to get something back from the server. For example, the last thing I did was to delete a to-do. The most likely outcome is that it will be successful and the server will return all the to-dos except for the ones that I just deleted. So we optimistically can update the cached response of to-do.all and manually delete the to-do that we know that we're just about to delete. So we can optimistically update the front-end side ahead of time. And most of the time things will go well. The server will say that was okay, the to-do is now deleted. But the benefit for the user is that it will be instantly. The to-do will be deleted instantly. Of course, we also need to handle the case that the server says, I couldn't delete this to-do. There was a server error or there was a network error, something happens. So we need to be able to roll back this optimistic update that we did to the client-side cache of the queries. So let's see how you would go about to do that. So let's start by optimistically updating the create-to-do mutation. So I will add the onMutate prop here and give it an async function. And as an input to this function, we get the new to-do. So the first thing we do is trpc.todo.all.cancel. And why do we do this? I think let's write a comment about this. Cancel any outgoing refetches so they don't overwrite our optimistic update. And the reasoning is that if there are in-flight queries, we cannot guarantee when that will come back. So to be safe, we say that any queries that are in flight right now, cancel them. don't care about the response of any in-flight queries. Then we are safe. Then let's create a snapshot of our previous to-dos. Previous to-dos. And we get that from trpc.todo.all.get data. Snapshot the previous value. Now we do optimistically update to the new value. So then we can do similar to this, but instead of get data, we set data. So if we hover this function, we see that the input is void or undefined. And since we don't have any input to this query, we can just set the first one, the input, as undefined. Then we have the updater function, where we get the previous value. Now we will create our fake to-do, our optimistic to-do. Optimistic to-do. It will have an ID. And this ID, we don't know what that will be yet, because that is something that the database will determine. It will generate an ID. So we can just call it optimistic to-do ID. We know what the text will be. That will be new to-do. We know that the text will be new to-do, but just to test this, we could try to set this text to just placeholder, because then we might see what happens in the front end when we do this optimistic update. And done, we know that that should be false, because this is a new to-do. So we also need to handle if we don't have any previous to-dos, then we can return just an array with our optimistic to-do in it. Otherwise, we return all the previous to-dos and we add the optimistic to-do to the end. So that is how we set the data, optimistically set the data. At some point, we also want to clear out our input form. That is something we can do here. Set new to-do is empty. And from this function, we also return our previous to-dos. So I mentioned that we also need to handle what if there's an error. If we optimistically set this data, what if there's an error? Then this is not valid anymore. So we will add on error. So we did clear our input up here. That is something that we need to set back. So we set back the input to new to do. We should also give an error to the user. So we'll do toast.error. An error occurred when creating to do. And now we need to set back the data. So similar to this. How do we know what the previous data was? Well, we do get some inputs to the onError function. We get the error, we get new to do, and the last one is the context. And from the context, we can get previous to-dos, the thing that we returned here from our onMutate. So now we should definitely try this. So remember, we did use the word placeholder for our optimistic update. So I'll do second to do again here. Let's clear this. And it was so fast we didn't really see it, but it worked. So if I throttle to slow 3G, third to do, we can see placeholder, and we can see that we have an all fetch that was in flight, and once that finished, we actually got the real name of third to do. So that makes it clear that that to do that was added was just an optimistic fake to do, but we know that most likely it will be there, and it will be validated once we get the server response. So what if there's an error? We can try that by throwing an error inside our router. So inside our create, instead of returning anything, we do throw new TRPC error. We'll just say code is bad request. Or we can say internal server error, maybe it's a good one. Internal server error. So now this will never finish. So what happens now? Now we get to try out the error case. Fourth to do. We see the placeholder, and now we should get the error. An error occurred when creating the to-do. So we can see that the optimistic update was actually removed, and I got my to-do text back in the input. So everything we did inside the on error seemed to work. We got the error message, we got the text back, and we set back the to-dos. So now we have a really good and snappy user experience with our optimistic update. So what's left is to do this optimistic update also for the toggle and the delete. So let's copy the on error and the on mutate from here, and then go here, and we'll start with the delete mutation. So here, instead of a text, we get the delete ID. We should cancel, we should get the previous, and when we set the data, this will be a bit different. If we don't have any previous, we just set the previous to-dos. But if we have previous, we can do previous dot filter, and we want to keep all the to-dos except, or we want to keep all the to-dos where the ID is not our delete ID. So that way we filter out that one to-do that matches with the ID. Then we should get the expected behavior of deletion. We don't need to do this, and we return the previous to-dos. And then we have the on error. We need to import toast. An error occurred when deleting to-do, and this should be the same. That should be it for delete. So let's copy this up to toggle. So as input here, we get ID and done. This should be the same. This should be the same. But the set data should be a bit different. So what we return here is we do a mapping of the previous to-dos. And if t.id is equal to ID, so if it is the to-do that we're actually toggling, we return we spread all the properties except for done, which should be set to whatever value that done is. And for the rest, we don't do any change, so we just return t. So we do a mapping, and if it is the to-do that we're toggling, we set the new done value, and for the rest of them, we do nothing. And this error message should be a bit dynamic, maybe. Setting to-do to, here we can do a ternary. If done is true, say done. Otherwise, say undone. And that should be it. So now let's test and see if it works. Now I have slow 3G on. So if it doesn't work, it should feel very sluggish. But if it does work, it should be really fast. And as we can see, it is really fast. It happens even before we get a response from todo.all. And if we delete one, it happens immediately. So I can verify that we do have optimistic updates. So I found a little error. Here we should actually use the ID and HTML4 ID so that they are unique. Otherwise, if they have the same ID, that is not good. So now that seems to be solved. I think we should also do a line through if it is actually done. So here we can do if done, add the class line through, otherwise nothing. That looks better. Now they're crossed off. And the final bonus thing would be if we actually finish the to-do, shouldn't we get a little celebratory message? So if we go to to-do and then we have the toggle mutation, let's add an on success here. So we get the same things as on error here, and here we get the new to-do. So here we have the done property. So we say if done toast.success to do completed, and let's have a popper. And a comma. All right, so let's try that. To do completed, and it doesn't fire if done is not true. So that's amazing. So let's sign out. And let's see if we log back in, if we still have our to-dos. Yes, they are there on my account. All right, so I think we are done with our application, but I hope you got interested in TRPC and learned a thing or two. I see TRPC as a really nice wrapper around a REST API that can handle the input validation really well, that gives you hints in the front end on what data to send, especially the way we did it in the create to do. You can do the SOD parse to make sure that the input is actually correct. And also the return types from our endpoints to get the type inference for that is really, really powerful. I think with this stack, it's really hard to make errors in the data going to and from the server, and that is really, really valuable. And I found it really fun to work in. So I hope that you learned a lot about TRPC. If this was your first time checking out TRPC, maybe you learned about optimistic updates and maybe some other things. So thank you so much for watching. Like the video, subscribe to the channel, leave a comment. What do you think about this tutorial? And I hope to see you in the next video. Bye!